This video goes over problems 3 through 5 in the application notes. A box is to be constructed from an 8.5 by 11-inch piece of paper by cutting out a square from each corner and turning up the sides. For what value of x is the volume maximized, and what is that maximum volume? So if we take a piece of paper and we cut squares out from each of the corners that are equal sized, let's call each of these cuts of length x inches. If I cut everything length x, what I'm going to end up with is a piece of paper that now has two sides that were 11 inches, but I've cut two x's off of them, and then two sides that were 8.5 inches that I've cut two x's off of. Then I have this third side that after I fold it into a box is x. So if I fold this, I now have an open top box where the top is open and the bottom down here is not open. So it's something that can hold things but has no top. So then what I look at, if I'm trying to maximize the volume, I have a height of x, a width of 8.5 minus 2x, and a length of 11 minus 2x. What I'm going to do is write that as a volume equation. So I'm going to write that as a volume equation, and then I will type that in the calculator, and I want to graph it. If I notice my normal graph, I'm not going to be able to see what's happening because this is going to be some volume equation, and the volume is probably bigger than y equals 10. So I have to change my window. My x's are fine, even though I don't really need any negative x's, but I'll change it. I don't really need any negative y's. So let's try up to 50. See if that's good enough. It isn't. So let's try to go a little bit higher. And I now have everything that I need. Now, one thing that I want to do, since I'm trying to find the maximum volume, and this curve represents the volume, I'm going to want to find the maximum. Notice that this goes off to infinity, but I'm not going to deal with that, because if I look at this 0, what I find with the 0 is it's at 4.25. And that makes some sense. After 4.25, I start getting into negative volumes, which don't make any sense. And the reason for that is I can't make a cut that is longer than 4.25 inches for x, because if x is 4.25, I've actually cut the entire side off because the side was 8.5. So that means a domain for my function is x has to be between 0 and 4.25, written in interval notation like that. So that means I'm not going to deal with anything over here. So this will be my maximum. So I'll do second trace to calculate, 4 for maximum. And then I just need to find the maximum, make sure that I put my boundaries in between them, and I find my maximum is at 1.585. So my x value is 1.585. And then the maximum volume is 66.148 cubic inches. Problem 4, a rectangle is inscribed in a circle of radius 2, and P is the point x comma y in quadrant 1. that is the vertex, that is one of the vertices of the rectangle and on the circle. So if you draw a picture of the circle, it would be this point, x comma y. So the first thing we have to figure out is, why are they telling us that this point is on a circle? Well, that means that I know that if I know a value of x, I can find the coordinate of y if I know the equation of the circle. So if I have a circle of radius 2, the first thing I'm going to want to do is write down the equation of that circle, x squared plus y squared equals 4. And then I have two problems. They want me to express the area and the perimeter of the rectangle as a function of x. So if I want to express it as a function of x, I'm going to need to solve this for y. So if I solve that for y, I get the square root of 4 minus x squared. That begs the question, why is it not plus or minus the square root of 4 minus x squared? Because whenever I take a square root in an equation, I should put a plus or minus. The reason it's not plus or minus is because since they already told me that this is in quadrant 1, I know that y is going to be positive. So I only need the plus case. I don't need the minus case. So now the next question is, what does this actually look like in terms of a rectangle? Sorry, I drew it like Indiana, or how the picture of the state looks. But if we pretend that I can draw a rectangle properly, what we notice is that if this is x and I travel all the way to negative x, these are both length x, which means the entire side is of length 2x. And that's true for all four sides. This is length y and this is length y, so that would be 2y. And so if I have a picture, what I need is a rectangle that has area 2x times 2y and perimeter 2x plus 2x plus 2y plus 2y. And what I'm going to do is every time I see a y, I'm going to replace it with 4 minus x squared as the square root of 4 minus x squared. So let's express the area, 2x times 2y, and then I replace y with the square root of 4 minus x squared, and this is what my area equation is. Likewise, I would do the same thing for perimeter. I add up all the sides, and then I replace the y with the square root of 4 minus x squared. So I now have expressions in terms of x. Now I need to find what value of x makes the area and perimeter the largest. So if I look at the area equation, I could type it into my TI. My TI doesn't really give me the best picture, so I also typed it into Desmos just so that we can see that it actually goes all the way down to 0. And the negative values of x actually aren't bad, because if I have a negative value of x, that would just flip my rectangle. However, because I know it's in quadrant 1, I'm only looking at x values, so in x values that are positive. So it's not like these wouldn't make the problem work. It just doesn't make any sense with the restrictions that I had, that quadrant 1 means that x and y both have to be positive. Because I can have negative values of x and still have this rectangle. It just doesn't make any sense with what they told me about where x comma y is. So what I would do is look for the maximum. The maximum is at x equals square root of 2, and the max area is 8. I do the same thing for the perimeter. So I write this perimeter equation. Then I did a Desmos and a TI graph, and once again I found out that the maximum is at the square root of 2. That's pretty interesting that the maximum perimeter and area are both at x equals square root of 2. So that made me think, what is going on? So what I did was I plugged square root of 2 back in to my equation, even though the problem didn't tell me to do that. And I found out that y was also equal to the square root of 2 if I plugged in or substituted square root of 2 for x. So this is my point. Then if I graphed it, I saw that that would actually make a square. So the maximum area and perimeter of any inscribed rectangle in a circle is going to be the one that makes a square. Problem 5, we've been asked to design a 1-liter cup shaped like a right circular cylinder. What dimensions will use the least amount of material? And we're told that surface area is not a liter unit. Liters are units of volume. And then if we don't know this from our metric stuff in science, we can look up and see that a liter is 1,000 cubic centimeters. So we should know ahead of time that the radius and the height of a cylinder cannot be negative or 0. So if I draw this picture, I know that the radius and the height have to be positive values. I also know, hopefully from geometry, that the volume of a cylinder is pi r squared h. Since I know that this volume is 1,000 centimeters, I can replace the v with 1,000 and then solve this for h. Now that's beneficial because since I also know the surface area formula, and that is the function that I have to minimize, since the problem asks me to give a minimum, I can then replace h with 1,000 minus, or 1,000 divided by pi r squared. So I'm replacing h with 1,000 divided by pi r squared, and then I do a little simplifying, and this is the function that I have to minimize. So after I look at this, then I'm going to type that in the calculator, remembering that r and h have to be positive values, and I end up with this value is my minimum. So the minimum value, which it's asking me to find the dimensions, minimum value is where x, when I type this in, or the radius, is 5.419 centimeters. Since I remember that the height is equal to 1,000 divided by pi r squared, I can take this r and substitute it in. When I substitute it in, 1,000 divided by pi times 5.4192587 squared, I end up getting a height of 10.8385 or 10.839 centimeters, which is exactly twice as big as the radius that we got. So these are the dimensions that that out of 1,000 cubic centimeters or 1 liter will minimize the dimensions. And I just wanted to put a graph of what it looks like in big picture terms and then a smaller graph over here. But the big picture terms, notice that there are a lot of negative values that are not part of the domain that we're not going to deal with. And as you make either, since x represents the radius, if you make the radius really, really, really big, or the radius really small and the height really big, you're going to end up with very large surface areas. But everything on this curve would represent something that has a volume of exactly 1 liter. So we want to minimize it as much as possible. And that's why we picked this minimum value at 5.419 centimeters for the radius and 10.839 centimeters for the height.